everybody, we're here at Funchess Hall, home of the Crop, Soil, and Environmental Science Department on the campus of Auburn University. They're just one of the departments that does research on precision agriculture. So come along with us as we learn more about what precision agriculture is and how producers in the state are utilizing these technologies. Hey everybody, we're here at Autauga Farming Company in Autaugaville, Alabama, and we're here with Drew Wendland and Dr. Brenda Ortiz, and I'll let you guys introduce yourself. Dr. Ortiz, you want to go first?
Yes. Good morning, everyone. I'm Brenda Ortiz, professor and precision agriculture extension specialist, and excited about this new series to show the Alabama community the role of technologies in agriculture.
And my name's Drew Wendland. I've been here at my family's farm, Autauga Farming, for about 6 years, and we have been farming here in Autaugaville for about 103 years. I manage the row crops here and use a variety of technology to help me make decisions every day.
Well, can we take a look at some of the technologies you're using in the field?
Sure.
All right, let's go.
Let's go.
Dr. Ortiz, so what is the definition of precision agriculture? What does that look like?
So precision agriculture involves the collection of data, collection of soil data, yield data, crop growth data on a spatial and temporal way. And that seems complicated, but crop fields are not uniform. If we fly over crop fields, we see a lot of variability, and this variability is variability in crop growth that is influenced by differences in soil type, differences in soil moisture, differences in topography. So right now we have a lot of computing and sensing technologies that were developed for other industries and now are applied. We can apply those technologies in agriculture to measure these changes in growth within a field, changes in moisture within a field, and all the variables, all the data that you can think of can be not only collected in real time, but mapped. We can create maps in real time of yield crop. We can create maps of soil texture. We can create maps of fertility, and we can analyze and combine all these layers of data, all these maps, and we are happy that farmers like Drew and many others are using the technology to implement what we call site-specific management, is applying the right rate at the right place at the right time with the right product to increase efficiency, profitability, and protect the environment.
So Drew, what do we have here?
So this is our nitrogen applicator. We apply a urea ammonium nitrate liquid in the ground. These coulters slice a band and then it injects the fertilizer in the ground near to the crop roots. And we use this tractor here with GPS guidance and some computer technology basically to apply different rates of fertilizer in different areas of the field based on yield factors that we kind of predetermine. But this is our rate controller. It feeds all the information through here into the cab, and there's a monitor in the cab basically that tells this what to do, and then it reacts as we drive based on the GPS location of the tractor. So monitor kind of talks to the GPS and to the implement, takes directions from me or what we've pre-programmed it to do, and then make sure that that gets done as we go through the field. And then also creates a map of what it did do. So we have, like, typically when we look at maps, we have target rate maps, and then we have as applied map where it may not have done exactly what I asked it to do for some reason, but you do have a record of what it did.
What are the benefits that you see through using this type of technologies in your farm?
So the biggest benefit is you can't manage what you can't measure. So first you have to know what you're working with. So like through history and stuff, we can determine where our better areas are in a field, or even if it's really simple, like just say a irrigated, non-irrigated, you just have two zones. Well, if I didn't have variable rate technology, I would have to take an average, and I would either choose a high number because the majority of the field's irrigated, and then I would likely be over applying nitrogen in areas that will never yield as much. And it's really hard to make those adjustments manually. It's pretty much impossible to change in the field if you don't have something like a rate controller that can say, hey, this is a high yielding spot, this is not. So we don't always see like, savings of inputs, but as better placement, you can put more where you need it and less where you don't. And I think that you get obviously better efficiency and more results out of the products that you do put down.
So get a better crop, better
Right.
harvest, because you've pinpointed what that soil looks like.
Oh, yeah, and initially I think a lot of people like to use variable rate stuff to try to achieve uniformity, and I have worked that angle also, but I think that once you get to a certain level of uniformity, you do have to look at, there are places that always do better and there are places that always do worse. And if you can quantify those places and draw a line around them on a map, and then you just treat them like they historically behaved. And that's what Trey helps me do with looking backwards at yield maps and creating our future plans from kind of our history.
So Trey, you're now here with us. Tell us a little bit about yourself and your role and some of the data that we're looking at.
Yeah, so I'm Trey Colley. I'm Senior Manager for Innovation and Equipment Technology for Greenpoint Ag. So Greenpoint Ag is an ag input provider, seed, fertilizer, and chemical, but also we offer agronomy and ag technology services within that. So my team and I function almost as advisors to the farm for all things related to ag tech. So, when we look across the farm, there's many ways that technology can help, for a farm to become more efficient or more profitable. So really we are just there almost as a accountant style of advisor for the farm. We'll look across the information that farm generates and provide recommendations, back to that farm to help them be a good partner with us through that journey.
Okay. So can you two walk us through some of the data and how you interpret it and how it all works together?
So really Drew and I's journey together has started with, let's start at the foundation and get our soils right. There's a certain level you have to be at for a soil to perform correctly. So what we see here on the screen is the first precision soil testing that we did on this field with them. And it's color coded by the lab, so any areas in red there are actually low in phosphorus for how we have this map pulled up right now. So the orange areas are kind of in the medium range, and there's no areas in the good or high range. So that was 7 years ago in 16. So we'll look at take you kind of on a journey of what we did to get this field right. So what we're looking at here is a map of 4 different years of yield maps. So we've looked at 2016, 17, 18, and 21. Those years we're laying on top of each other and saying what consistently is a high performing or low performing area within that field. So we're going to use that to inform moving forward how do we address or maximize potential in those areas.
And on elementary level, basically the red is below average, the white is average, the green is above average. So instead of treating this field as an average, we're going to treat it as subfields kind of that have 3 different characteristics: the highest producing, the lowest producing, and then what's right in the middle. And then we try to figure out why and we'll either manage to sometimes we manage to level it out to try to eliminate the differences, and sometimes we manage to take advantage of the strong suits, and we push the best stuff harder, and we put less inputs in the weakest. So it takes a lot of like retrospective data analysis to look at like what makes a red area red, and then what could be done. Can anything be done? And if it is, what kind of, where should we start to bring it up, bring its productivity up?
And so we started with a lot of red areas on that soil fertility map, right? And so what we've done between now and this map is we've applied fertilizer at a variable rate to correct some of those poor fertility areas. So now we have somewhat of a more level playing field, and we're able to use this information to go to the next step. So what we've done then over the years is say, okay, we have our initial soil tests. Now we also have our yield layers in there. So what we've done here is we've taken, and instead of having a very intensive every couple acres soil test, what we're doing is creating a zone of similarly performing soils. So we think of it as like a ranking. So of the areas within this field, we have our top and lower performers, and we're treating them as a unique field within a field, I guess. So in that way, we're able to more efficiently manage inputs for each of those regions as they perform. And so this is an example then of those same zones. What we did was we got the soil analysis back for the zone sampling, and we had a reference of those harvest layers. And what we're actually doing now is we are setting yield goals for each of those zones. So we know, for example, that the red area in the middle of the screen there is 260. That's a very high performing area of the field. So we say, all right, let's maximize, the yield potential there. We'll spend more money to try to make more crop there. Whereas kind of on the right side of the screen, you see that circle that's cut through the zones.
Kind of right through here.
Yep.
That's the edge of my irrigation pivot.
Everything to the right side of that is 175 bushel yield goal, because we know that due to water limitations, we don't want to put a lot of money into that area. So in the instance of if we didn't have this technology, we would probably be running a single rate of fertilizer across this whole field, spending too much outside of water, and maybe leaving some yield on the table in those high performing areas.
And then sometimes we change our mind. So we may decide in 2 months when I'm done, or in 3 months when I'm done, that we don't like this for some reason, and we'll just do it a different way. There's like probably some standards that y'all operate on that kind of like guide the direction that most people go, but it's really like your own playbook, and we can change it any time.
When do you start meeting to come up with your game plan? Like, when's all this?
So we want to have as much communication with Drew or any grower that we work with as we can. So we try to offer tools that help them out at every point of the year. So we're talking about planting prescriptions, irrigation monitoring, aerial imagery and tissue sampling during the season, harvest analysis, and then in the wintertime, budgeting and planning headed into the next season. So we're talking, I would say all through the year, but then it is that kind of wintertime where we're really making detailed plans for the next crop. But yeah, this would be kind of an example of the culmination of all these things coming together, and that would be a profitability map for the field that we're looking at. So this would be an example of one of our wintertime meetings where we're really evaluating the processes that we're doing with this farm. So Drew and I would sit down and we'd say, hey, here was the amount you spent on inputs, fertilizer, seed, chemical through the year. Here's your machinery costs, labor costs, overhead, things like that. And then by using all the not only records but spatial information from their machinery, we're able to say, all right, in this area, here was your return on investment. So 16% just in this one example. But what we're able to do is start thinking about fields in terms of ROI, return on your dollar spent of inputs. instead of thinking about how much did I yield, or how many acres did I have in production this year. It's really a powerful tool for us to be able to partner with Drew in that. For him to be successful, we're enabling him to be successful, and then in turn, being a good business partner. So
you try to look at what the variables are, and then if you go back to go to that tab, Abigail, if you will. Every different number in here represents a different yield goal, but the yield goal is reflected by the amount that you put into it. So every single one of these, I targeted something different, and then if you go to that back where we just were, you can see that this would be a pretty successful year, because even though we had so many different goals, our profitability was pretty good all the way across, and that means we kind of did it. That means we did it right. So we spent less and less areas, but we were still able to make money there because I didn't overspend there. And being able to make a green profitability map out of a multicolored rainbow map before, that's kind of the end goal.
So one note I would say, through this too is, this is our 7th year, kind of in the ag technology space with this farm, and a lot of people see, this or other, end goals of technology use, and they don't see the steps that they can take to get there on their farm. So there is just as simple as soil sampling. There's many companies that offer that service, variable rate application. So those little things, there are little steps and pieces that fit every farm as relates to ag tech, but not every technology solution fits every farm. So that's been a good kind of motto for us, is saying, hey, there is ways that we can help you for your unique operation. And like Drew said, for the ability just to not spend less dollars, not necessarily spend more dollars, but to allocate our dollar to be at its maximum potential is really what we're after here.
We're here at Sermon Farms in Daphne, Alabama, and we're here with Joel Sermon. So Joel, tell us a little bit about your farm and what you got going on here.
This is Sermon Farms. We're a partnership with my brother. My wife's the bookkeeper, and my mother's still involved a little bit with the farming, but we grow cotton, peanuts, sweet potatoes, and some corn. When we first started, my father was a dairyman, so we had hogs also. Then we grew vegetables, and now we had row crop.
And you're using some precision agriculture on the farm?
We're using precision ag on our planters for planting cotton and corn. And then we also, on our sweet potatoes, we have a precision ag on the side shift for the sweet potato, putting it on top of the bed.
All right, well, can we take a look at some of the equipment that you're using? So we're here with Greg, the farm manager at Sermon Farms. So Greg, tell us a little bit about yourself, and then can you show us some of the equipment?
I'm a 2014 graduate of the College of Ag at Auburn. Graduated with a degree in ag economics, and farm manager here. This is where I'm originally from. Came from a career in the research world, so I've done a lot in my short time since leaving Auburn. So this is one of our planters. It's just a single row, 38-inch row spacing 12-row planter. We utilize these row cleaners. They've got, it's all pneumatic, and we can adjust that from the cab based on how conditions are. So if we want to no-till, we can do that. Fully adjustable, does a really good job and helps us, get a clean seed bed opened up. We also utilize hydraulic downforce to make sure that these row units are staying level and putting the seed in the right spot. Emergence is key. You want everything to come up at the same time. Anything, outside of that 24 to 36 hour window is almost like a weed then, because it's getting out competed by the other plants. We've got smart firmers down here, and that's reading our soil organic matter, our soil moisture, our CECs and things like that. So we can set it based on a moisture threshold, especially with variable fields. And in cotton, you can have everything imbibing that moisture to get germinated at the same time. So we can set that depth based on a variety of factors, and it can automatically adjust.
So you're wanting the seed to go down at a certain depth across the whole field so that it grows at the same time so you can harvest it at the same time.
We
Correct?
want consistent emergence, whether that's, so the downforce plays a big part in it to make sure that it's at the right spot. But more than anything, it's emergence, not
Okay.
necessarily depth.
Okay.
It's important, but we want everything to be in moisture, in the right amount of moisture. So
And with the old planters, you filled this up with seed, and it was heavy, so you bogged down. As you got seed out, it picked up. Well, this is controlling that depth.
Oh, that makes sense. Okay. Yeah.
the downforce, the hydraulic downforce, just as important as putting pressure down in a lot of our lighter soils, it can pick the unit up to make sure that you're not smearing your seed trench or anything like that. So it's just it's all a big component to our operation.
Yeah. And it senses that, and so you manage all that in the cab while you're doing it, and it just senses it and knows what to do?
So all of that is managed in the cab through a screen in there and an iPad with an internet connection. So as we're running this planter, you can make adjustments on the fly. And I always say this is one of the most important tools in farming today. So anybody can, any one of us can look and see what this planter's doing in real time.
And you can see this is an old planter, and Chip was good enough to go put all this stuff. Instead of us buying a brand new rig, we retrofitted this thing
outfitted you.
on it,
Yeah. Cool.
It's a learning curve
Yeah.
for sure. And like Joel was saying, it takes, you've got to have kind of a technology mindset. And it's hard, that's why we try to adopt something every year or, as time goes, because at some point you're going to have to kind of move and it's a lot easier to add on one or two things than to have to start from the bottom and come to something like this. It's just technology's moving so fast, and I'd say we're definitely on the early adopter range of the scale, and you get to kind of see things firsthand and how they improve our operation.
And are you starting to see all that? Are you starting to track all that of how much it's helping you?
So they've been tracking a lot of this, have the data for years, but the thing, everybody talks about data and collecting data, but interpreting it is such a big part of agriculture. And you have to have good partners to work with, because this is, we're still a small operation as far as employees and things like that. So just having hours in the day and somebody that knows what they're looking at to help us out. We've got several good partners in that.
Megan, this is Chip Briers. He's our technical support with Vantage South, and he helps us a lot with all our precision equipment.
So how do you work, Chip, with farmers and producers directly?
So we work closely with growers in our area to try to identify areas that they may have some low-hanging fruit in terms of efficiencies that we can gain. So we work with them to evaluate those areas, find what sort of technologies and solutions can help them become more efficient. We'll evaluate those technologies with them and see what fits best with their operation and their existing equipment. And once we've made a selection on what they're going to use, we go to their farm and help implement that technology on the farm. So we make sure that everything's installed and functioning correctly, that all the operators know how to work it, and that they're using it to its fullest extent so they can capture those gains in efficiency.
So what are we looking at here?
So this is the Sermon sweet potato inverter, and we have a Trimble True Tracker system installed on the hitch of this tractor. And what that allows our autopilot to do is control the hitch as well as the tractor. So the tractor is driving itself, and then the hitch is driving itself independently of the tractor. So when these guys bed up and plant the potatoes, they're utilizing this hitch, and that allows us to come back and be in the exact same place when they come to invert for harvest. So all of these systems are running a sub-inch repeatable level of accuracy, meaning that when they come back later in the year to harvest, the line that they use to plant and to bed up is going to be in the exact same place now that it was when they planted. And that makes sure that when they're inverting the potatoes, if they're too far one way, they're going to be cutting potatoes and damaging the quality of the potatoes. If they're too far the other way, they're not going to be flipping all of them over. They're going to be leaving yield in the field. And this helps make sure that they're in the exact right spot when they come back to invert.
That's pretty cool. So the machine is remembering exactly where it went and the route it took, and then when it comes back, it remembers all of that.
Right, and then having the ability for the hitch to drive itself as well as the tractor. Sometimes the beds get tight and it's difficult for the tractor to maneuver, but the implement can still maneuver to be in the right spot.
We find it's hard to plant on a bed with the sweet potato planter because it wants to run down the hill, and this prevents that from doing that and keeps it right up on top.
That's pretty cool.
And then when we digging, it knows where it's going and turns them up. Then we also have people behind us picking up by hand. We got machinery to dig, but the way we do it is a perfect product. Everybody wants a perfect sweet potato. So
Yeah.
no bruising.
We still haven't come up with a machine that can pick up a potato as well as a human hand.
So it just makes your life a little easier, and hopefully you're making a little bit more money, right?
And now, when an employee goes to the field, if the auto steer is not working, he calls and said, "This tractor's broke down," because they depend on this stuff now. So
Everybody's forgotten how to hold the steering
Yeah.
wheel these days.
before, we used to
Yeah.
drive by hand. So
Yeah. All right, so tell us about the sprayer here.
So this is our peanut sprayer. It's 120 foot wide. Utilize auto steer technology on it to run the same track, repeatability, and we've got the capstan system on it. It's I believe the phrase is pulse width modulation, basically at a pulse, so we can maintain consistent pressure across the field, so we're putting out the same rate equally. And it's got turn compensation, so if you think about the width of this, if you're making a turn, the outside is moving a lot quicker than the inside, so they can speed up or slow down the pulse in order to maintain that rate. And it's got, whereas a conventional, each section would be conventional section control, so if you shut it off, you're shutting off 10 or 11 nozzles, and whereas with this, each individual nozzle is able to be controlled, shut on and off, and we see a really big chemical savings, and cuts down on off-target movement and drift. That was what I was getting at with the development that we're seeing in our area with subdivisions and everything else. Feel a lot more comfortable, as you see it runs right up to the edge of somebody's yard. You feel a lot more comfortable, and can be a better neighbor, control our movement of everything we have.
So tell me about each of your experiences. So what, with what you're doing now, how do you think your degree or just your experience in general, when we talk to students, we tell them it's all about gaining that experience. And so taking part in research, being in clubs, doing internships, things like that kind of help set them up for success. And then, so talk me through that. What do you think were some of the key things that helped you become successful and get to where you are?
I think for my standpoint, with the program I was in being so new, there were some kinks to be worked out, but it came in at a perfect time because growing up on a farm, I wanted to stay in agriculture, but I also loved the technology. And so it was really perfect for me and opened a lot of doors. As far as just things that I learned through college, was that involvement was so important. And now that I've graduated, I have friends in different places because of that, but also just being involved in local young farmers or cattlemen's or anything like that has been very helpful, because anybody I worked with in Auburn or interacted with, I'll be working with in the future and interacting with there.
I think that's a really important point, is to broaden your line of thinking, not just, saying I'm a biosystems engineer, that's my major, and this is what I can do, but to be whole and encompassing of, exposing yourself to different departments or interests will make you a more well-rounded individual.
Yeah, and the reality of it is, when you look at those disciplines, they're all working together, right? In some way, shape, or form, you're all coming together. So, fun fact, at Camp War Eagle every year for at least the past 2 years, I tell students, I make them stand up and look around at each other, and I make them, we talk about how you're going to be in classes with these people, but I'm like, but you're also going to be, and you guys hit on this, you're going to be colleagues, and you're going to be working together, and you're going to be tapping on each other's shoulders, and you're like, I need your help with this. So this is like it playing out, I'm not just making stuff up. You guys are really living that out of getting to know the people in your classes, asking questions, and seeing it from different angles. So
it really is true. I mean, there's no telling how many people we work with. I mean, I can think of 25, 30 examples just from our class and one class above, one class below.
Yeah.
People we work with on a weekly and monthly basis. So relationships is the name of the game.
what kind of opportunities are available for students maybe wanting to do what you're doing?
I would say there's a ton of opportunities, because I think precision ag is a big part of the future of agriculture. So I'm not the farmer, Joel's the farmer, and he knows way more about the trends in ag than I do, but I've been around it for quite a long time, and I see technology and the pace of change in ag is continuing to pick up. We're right on the cusp of some really kind of revolutionary technologies with artificial intelligence, autonomy, and robotics starting to go to the field. And farmers now and farmers in the future are certainly going to need people who can competently use those technologies to gather data, to make meaningful decisions based off that data, and then execute on those decisions using increasingly technical pieces of equipment. So I think there's definitely going to be places for people who have those precision ag training and skills in the future of agriculture.
I work with a big team of students, graduate students, undergraduate students. So every summer my team grows because we need to collect a lot of data. We do a lot of training. So there are normally 5 to 6 undergraduate students in my group every summer. And some of those students come thinking that they are going to stay for one summer. They really like so much what we do in the program that some of them have stayed 3-4 years until they graduate from Auburn. So, and I have students not only from the Crop, Soil, and Environmental Sciences Department, but I have had students from Ag-Econ, from Biosystems Engineering, from Ag Science majors, from Entomology and Plant Pathology. So you don't have to be a student, undergraduate student, in one specific major. This precision ag is a big umbrella, so there is room for everyone. Even our communication students have been part of my team. So and undergraduate students learned a lot. When some of my graduate students graduate, they get jobs as extension agents. Some of them have graduated with a master's degree, went to another university to get the PhD, and now they are assistant professors. Other students are working as scientists for federal labs. So they get a lot of experience, hands-on experience, that really prepare them to better serve the farming community.